So my name is Rendy. You can call me Rendy. Today I'll be presenting my study about the impact of regenerative design solution on indoor temperature and indirect access in regenerative residential building in tropical city. So as a background introduction, as we know that global temperature is rising, and also tropical region are geographically located in areas that is in high vulnerability to climate change. And Jakarta, Indonesia is also one of the fastest growing cities in developed countries in tropical regions. And from the literature review and the background, this study identified gaps that includes inadequate practice of acknowledged regenerative design projects that address multi-story residential buildings in warmer climates, and also lack of passive design strategies and thermal comfort studies related to multi-story residential buildings in Indonesia. So also for the research aim for this study is to examine the feasibility of regenerative design in a typical medium-rise residential building in Jakarta, Indonesia. So there has been a growing discussion about regenerative design, which is going beyond net zero. So for this study, the methodology is divided into three major steps, which is the stage one is the analyzing the baseline design performance. So for this study is using the design prototype from Indonesian government's medium-rise building. And the second stage is optimizing the design with iteration process in DesignBuilder software. And the third stage is to compare the result of the optimized version with the baseline version. So the metrics used in this analysis for the indoor thermal temperature is using ASRAE 55 adaptive thermal comfort, and for the daylight access is using the climate-based daylight modeling, which is useful daylight illuminance and spatial daylight autonomy. So for the iteration process, there are several regenerative strategies that is implemented in the buildings, which is include cross ventilation, night ventilations, improving external wall materials and insulations, and also applying external window side fins and light shelves, and green roof for the rooftop area, and also implementing the photovoltaic on the green roof for energy generation. So the results is divided into three aspects, which is the thermal comfort, daylight access, and energy analysis. From the thermal comfort, it is determined by the number of days in a year for each room that achieve thermally comfortable. So for the optimized model, it managed to improve all the zones in all floors to have 90% of the time thermally comfortable without any mechanical systems. But throughout the future climate in 2050s and 2080s A2 scenario, it continuously decreased, like around 70% in 2050s and around 20 to 25% in 2080s. And for the daylight performance, it also shows a reduction in the performance of UDI and spatial daylight autonomy, which might be caused by external window side fins, and also the light itself did not really significantly improve the indoor daylight performance. And also in terms for the energy analysis, the interesting findings is that the produced electricity is only improved by 2.6% in the 2080s compared to the 2020s. But the cooling demand in the same period increased by 8.4%. So it shows that the energy production did not really keep up with the increasing demand of cooling energy. So the conclusion is that in the strategies implemented, such as cross ventilation, improved insulation, photovoltaic and green roof systems, it could improve the indoor thermal comfort in the 2020s climate scenario, but it could not perform really well in the future climate scenarios. And also meeting the energy demands of the medium-rise residential buildings solely with photovoltaic panels in the future will be increasingly challenging if the building use mechanical cooling systems, and the energy generation will not be able to keep up with the increasing temperature and increasing energy demand. And that's for the further research. It might be beneficial to add more regenerative solutions or improvement strategies on the building to make it more resilient in the future climate. Thank you.